Math might be the last thing that comes to mind when you think about sports. But in reality, there are tons of different places where it can be used. And that's especially the case for quadratics. Since parabolas are used in projectile motion problems, which is just a fancy term for anything that's launched into the air. For example, it could be used to find the secret to a perfect free throw, or even a penalty that always ends up at the back of the net. It can even be used in extreme sports too, like BMX and dirt bike racing. This is a motocross race, where some of the best bikers in the world take on high-speed corners and jumps like these. As you can see, this biker gets a lot of airtime, but how exactly can we find out how far he's traveled while in the air? Well, the path of the biker can actually be estimated using this parabola. A in this equation is unknown to us, but we do know the vertex. Given this information, will we still be able to find this distance? The first step is to label what we're solving for. Let's call this point A and this point B. The distance between these 2 points is what we're trying to find. If you look closely, you'll notice that both A and B are roots of a quadratic. We can solve for one of them very easily, since they give us the quadratic in factored form. We simply set the group x minus 7 equal to 0. This gives us a root of positive 7. The tricky part is finding the other root, since A doesn't really tell us anything about the quadratic. But luckily, they give us the vertex. And from the previous question, you may have picked up that the x value of the vertex slices the parabola perfectly in half and is called the axis of symmetry. Because of this, the horizontal distance between the x value of the vertex and one root will be the same distance as it is from the other root. So let's start by drawing a little line up from the vertex and onto the x-axis. This signifies the x value of the vertex, which is 4.5. Now the distance from here to 7, which is the root we know, is 2.5, since 7 minus 4.5 gives us 2.5. This means that the distance from the unknown root to the axis of symmetry will be 2.5 as well. Therefore, the total distance from point A to point B will be 2.5 plus 2.5, which is just 5. Our next question takes us to Brazil, home of the most popular sport in the world. No matter what you call it, it characterizes Brazil's culture and unites people of all ages. From kids playing in old fields to national heroes competing in the most iconic stadiums in the world. Today, we'll put ourselves in a player's shoes and take a deeper look into one of the most critical parts of the game, a penalty. Most will tell you to aim for the corners, tempting the keeper towards one side and striking the ball into the other. This strategy works, but some players decide to be even more unpredictable and go straight down the middle, betting on the keeper diving towards either side and leaving the center wide open. It may sound easy to just kick the ball down the middle, but it's harder than it looks. Because if you hit it flat and keep the ball on the ground, you run the risk of the goalkeeper's body blocking your shot. So the trick is to chip the ball and get just enough height so that the ball rises, reaches a peak, and then comes back down. This is exactly what this player does. Say we use the equation a equals negative 3t squared plus 15t to represent the ball's path in the air with respect to time. A stands for altitude, measured in feet, while t stands for time measured in seconds. How many seconds will it take for the ball to reach the ground again after it's kicked? These questions might seem overwhelming at first, especially if it's your first time seeing them. So let's build some intuition with a quick sketch. We know this equation is a quadratic, since it has the t being squared. We also know that the parabola opens downward, since our a is negative 3. Our y-axis in this problem is altitude. Usually we have y equals the quadratic, but in this case we have a equals the quadratic, and a stands for altitude, which is just a fancy word for height. Instead of seeing x squared, we have t squared, and t represents time, so we know the x-axis is time. Now we just have to reason through the rest of it. When t equals 0, the ball hasn't been kicked yet, and is still on the ground, so its altitude is 0, which gives us the point 0, 0. Then as time goes on, because we know the quadratic opens downward, it will reach its peak vertex and then come back down again. The point where it takes off and lands forms the roots of the quadratic. And remember, roots are always x values, which in this problem signifies time. Therefore, our roots will tell us the time it takes off, which we already know is 0, and the time it lands, which is what we have to find in this problem. Therefore, now all we have to do is figure out a way to find the roots of the quadratic equation given to us. Now, we don't have to draw this every time on the test. As long as you have a mental picture of what's happening, you can dive straight into solving for whatever you need. So let's take a look at the equation. It's in standard form, but we have two problems that make this equation look a bit unusual. One is that it has an a value that isn't 1. On top of that, its c value is 0, since there isn't a number being added or subtracted at the end. These are signals telling us that the traditional way of factoring isn't the best way to solve this problem. Instead, we should look for something these two terms have in common. If you look closely, they both have t's in them. So t is a common factor that we can pull out of each term and use to rewrite the equation. We also can factor out a 3 from these two terms, since both are multiples of 3. So let's pull out 3t. When we factor out 3t from negative 3t squared, we're left with just negative t. When we factor out 3t from 15t, we are left with positive 5. Last, we set each group equal to 0 and solve for t. The first group gives us t equals 0, which we already know is the starting point, before the ball is kicked and is still on the ground. When we set negative t plus 5 equal to 0 and solve for t, we end up with t equals 5. So exactly 5 seconds after the ball is kicked, it'll reach the ground and end up at the back of the net.